Hi, welcome to this lecture on building a regulated power supply. Now in a previous lecture we talked about power supplies in general and all the steps needed in order to create a stable DC voltage for electronics. In this lecture we're going to talk about some of the practical chips we use to build a regulated power supply. Okay, so just to kind of briefly summarize again, when we're creating a power... Okay, so just to briefly summarize again, when we're going from an AC input to a stable DC output, we have a whole bunch of steps: the AC line filter, the transformer, the rectifier, another filter, which is usually just a big capacitor, and then finally a regulator. Now, if you were to just go to the store and buy an AC to DC transformer adapter, I just call it a wall wart, then what you're actually buying is all the steps prior to here, typically. So you get everything except the regulator portion of it, which means that this is an unregulated DC output. So if it's unregulated, that means it's just the output from the filter. So you'll have things like ripple. So you may remember that our rippled output looks something like this instead of being a constant DC. And it may fluctuate a little bit based on noise coming in on the AC line input. So it's not incredibly steady, and an unregulated power supply is not suitable for running your digital electronics. If you have slight voltage dips and drops, that can cause your logic chips to think they see a 0 when they should see a 1, or vice versa, and it'll cause logic errors and could damage the chips as well. So ultimately, you need to take that unregulated DC output that comes from here, and you need to produce regulated DC output. So for that, we're going to use a regulator. Now, the most common regulator that seems to be used for 5-volt circuits, and there's a lot of 5-volt circuits, would be a 7805 voltage regulator. So a voltage regulator, as we've mentioned before, is a semiconductor device that converts an input DC voltage into a fixed output voltage. The 7805 produces a 5-volt DC output, but in order to do that, it needs at least a 7.3 volt unregulated input. So if you're using a DC wall wart, or even batteries, you can use batteries with a 7805 as well, then you need to provide at least 7.3 volts on the input in order to get a stable DC output. And the reason you need that extra voltage is so that the voltage regulator has some extra voltage to play with if there tends to be a drop or something it needs to correct for. So why use the 7805? It's kind of a typical regulator that we use, but some of the nice features about it, it's got an output current up to 1 amp. And when you're dealing with digital logic only, 1 amp is a lot of power. It creates an output voltage of 5 volts, and lots of digital logic chips run off of 5 volts. It has thermal overload protection, and what that means is that if the chip gets too hot because you're pulling too much current through it, then it'll automatically shut itself off instead of, melting your circuit and your board. Although it can still melt your circuit and your board. The thermal overload protection may not kick in fast enough for you. It has short circuit protection, which means that if something happens and the chip malfunctions, you're not going to short circuit your unregulated power into your circuit, potentially damaging your chips. And it's overall a very versatile, easy to use chip, and it's necessary when you're going to deal with high current sources, like if you're going to use a 6-volt battery or something like that, it's useful to protect your integrated circuits. So the 7805 comes in a variety of packages. This is a screenshot from the data sheet for the chip. So a variety of different packages and types, and there's more than this as well. And so you'll see one of these when you work with these in lab. But this right here, for example, is the package that we tend to use, which is a 3-pin drop-in chip. In fact, it looks like this. So you have 3 pins, 1, 2, 3. And this is a 7805. You can see that because it's written on the chip itself, L7805CV. And then it's got this big hole and screw on the top, which interestingly enough is for adding a heat sink if you need to. Because if you're actually going to pull the full 1 amp through this chip, it's going to produce a lot of heat, and you need to dissipate that heat using a heat sink, or your thermal protection is going to kick in and disable your chip. So for example, when you wire this thing onto a breadboard with a few other components, usually some capacitors, you may end up with a circuit like this, although the one that's typically used is even simpler than this with only 2 capacitors. So the 7805 is actually part of a series of regulators that I'm just calling the 78XX because the XX can be filled in with some number. And you'll see a pattern if you look at this table here, that the 7805 produces 5 volts, the 7806 produces 6 volts, the 08, 8 volts, etc., all the way up to the 7824, which produces 24 volts. So the 7805 is just one of this family, but the family is all used in roughly the same way, roughly the same circuit. They just produce different output voltages if you need a different DC output for whatever your electronics are. Typically, though, you're going to want to be working with 5 volts. So if you want to use a 7805 regulator in your circuit, how do you know what other chips to connect with it? Kind of like the diagram I showed had capacitors and stuff. How do you know which ones to use? Well, the best bet is to just look at the data sheet. So you go to the data sheet for the chip, and it'll have a little circuit in there, recommended usage, and that's a good place to get that. Now, another type of regulator that I wanted to look at is an adjustable regulator, and this would be the LM317. Now, the LM317 is one chip that can be used to produce any regulated output between 1.2 and 37 volts. And this is useful because that means that you can produce a wide variety of output voltages within any specific set of values that you need. And in this case, you adjust those voltages based on the values of some resistors that are in the circuit. So if you use resistors, then you're going to calculate based on the resistors what the output voltage will be, or you could use a potentiometer, which is basically a variable resistor, and you could create a variable power supply, meaning that you could tune the potentiometer and adjust the output power. So let's look at a sample circuit for that. So if we take some input from, say, the wall, and we run it through our standard stuff to get an unregulated output, well, then we feed that into our LM317, which has 3 pins, V in, V out, and what we call adjust. Now, the adjust pin is wired in with 2 resistors, R1 and R2. And based on the values of those resistors, you can use a very simple calculation to calculate what the voltage will be at V out. So if you vary R1 and R2, the output voltage will vary as well. So if we were to fix one of those and make the other one adjustable based on, say, a potentiometer, you could adjust this circuit to be whatever regulated output you need. Okay, so let's review. Voltage regulators produce a stable DC output, and the unregulated input needs to be a higher voltage than the expected stable output. And the data sheet for your regulators will tell you how much higher you need. And a stable voltage source is required for correct logic circuit operation, which is why we use a regulator in the first place. If we use unregulated power to run our logic chips, then we could have errors or even damage to the chip. So we run it through a regulator first to get as stable of a DC output as we can. Thanks.